this is a rather technical section. You already know how to make regression estimates, so in some sense you don't need to write it all out in the form of an equation, but regression equations are seen everywhere in statistics and you need to know how to read them. And so we are going to write the equation in 3 ways. The first is the way we already wrote it, in English. The estimate of y in standard units is r times the given x in standard units. We've used that a few times. You want it in math notation? Here it is. The estimate of y in standard units of y, so you start with the estimate of y, you subtract off the mean of y, and you divide by the SD of y. I'm using the same notation that I have used in an algebra supplement. You can call this, you can simply write out the word mean of y here and the words SD of y down there if you wish. So this is the estimate of y in y standard units equals r times the given x in x standard units. Precisely the same thing written out in notation. So this also is the equation of the regression line. But people love equations of lines in what is called the slope-intercept form. And so they want the equation to look like this. The estimate of y is some slope times the given x plus an intercept. So how do we figure that out? Well, we just rearrange this equation up here. So multiply both sides by the SD of y, and then you'll see that this SD of y will go up to the top here, and then add the mean of y to both sides. And if you sort out that algebra, you will get the slope of your regression line is r times the SD of y divided by the SD of x. And the intercept is the mean of y minus the slope times the mean of x. And those of you who are good at algebra will have worked this out in your head already, and those of you who don't want to bother with the algebra, don't bother with it. You already know how to make the estimate. And so what has been written here, the third form, is exactly equivalent to the second form, which is exactly the same as the first form. You remember the equation any way you wish. What I'll do now is I will examine the third form, because the third form is one in which it is commonly written in other places, and show that that establishes for us that the point of averages is on the regression line. And so what was the equation? Well, you've got the estimate of y is slope times x plus an intercept, and you've got a formula for the slope and intercept. What I'm going to do is I'm going to plug in the average of x, where I'm seeing x here. So if I plug in the average of x, then what will I get as my estimate? Well, I'm just going to plug it into this equation. I'm going to slope times the average of x plus the intercept. What's the intercept? Here's the formula for the intercept. So I'm just putting it down there, and now I step back and I look at it and I'm saying, slope times the mean of x minus slope times the mean of x. Well, that goes away, and all you are left with is the mean of y. So we started out with this as a natural idea that the point of averages should be on the regression line, and here the algebra has established that as well. The point of averages is on the regression line, or in other words, the regression line passes through the point of averages. And all those among you who tuned out over this algebraic portion should tune back in to this English language sentence that says, your line of estimates will go through the point of averages. In other words, if I tell you that the person's weight was at the average, then your regression estimate of height is also going to be the average of the heights. So, shall we put some numbers to this? Let's actually find the equation in a particular case. So here's our distribution of heights and weights, correlation, and a football-shaped scatter. And this time what I'm going to do is I'm going to say I am going to give you the person's weight, you estimate the height. Find the equation of the regression line for estimating height based on weight. So what's x? X is what is given, so x is the weight. And then y is the thing that you're trying to estimate, which in this case will be the height. So how do you find the equation of the regression line? You first find its slope and then you find its intercept. Slope, r times s dy divided by s dx. And that you get is 0.09 inches per pound, because correlation has no units. This is 3 inches divided by 20 pounds. And the intercept is the average of y minus the slope times the average of x. So the average of x is 160 pounds. The slope is 0.09 inches per pound. So when you multiply, you get inches. And once you've done the calculation, you have 52.6 inches as your intercept. So what's the equation? The equation is that your estimated height is 0.09 times the given weight plus 52.6. That entire thing is your answer, because you are asked for an equation, and so you'll present an equation as the answer. So what is this for? This is for estimating height based on weight. So if I give you a weight, you are simply going to plug into this equation and out is going to pop your estimated height. So let's say I tell you that the weight was 100 pounds. Then you will plug 100 pounds into this equation and out will pop your estimate of 61.6 inches. And let's check that at least ballpark makes sense. 100 pounds is below average weight. And so you're expecting a below average height because your correlation is positive. And indeed, 61.6 is less than 67. So what have you gained from this? Well, really, you could have done that estimate some time ago. You would have converted 100 pounds to standard units, multiplied by r, and then converted that into inches. So you could have done that without the equation. What this is useful for is if you have several weights. One person weighs 100 pounds, find their estimated height. Another person weighs 180 pounds, find their estimated heights. If you have a succession of these to do, then it's useful to have that one equation into which you keep plugging in different values of the weight. So it's handy in that case. And what I'd like to do to finish up is to examine this quantity, the slope of the regression line, 0.09 inches per pound. What exactly does that mean physically? So it's the slope of a line, and the slope of a line means rise over run is what we're used to saying. But what it means is for every pound increase on the horizontal axis, your line goes up 0.09 of an inch. In other words, for every additional pound, your estimate of height goes up by 0.09 of an inch. And just to be clear, let's think about what that might mean. Could it mean that if one of these people puts on 1 pound, that we're saying they're going to get taller by 0.09 of an inch? That just sounds very weird. Surely this cannot be. And why can it not be? For a reason that you have seen before. We are not watching the same person eat ice cream and get heavier and heavier. We have a snapshot of a population at a certain moment. And so what this slope means is if you start with people of any given weight, take everybody of any given weight, and then look at a different set, that is all the people who are 1 pound heavier than this group, then the heavier group is estimated to be 0.09 inches taller on average. So the slope is comparing two groups of people of different weights. It has nothing to do with one person getting heavier. And this idea can be used to simplify some calculations. For example, if I tell you that I have two people and one of them's 5 pounds heavier than the other, then the heavier person is estimated to be taller by how much? Well, for every pound heavier, the person is expected to be 0.09 inches taller. These are two different people. And so for 5 pounds heavier, since we are using a straight line, your estimate is expected to be 0.09 times 5, that is 0.45 inches taller. And once again, you're looking at two different people. One of them is 5 pounds heavier than the other, and the heavier person is estimated to be 0.45 inches taller. And it's worth keeping in mind that regression is about averages. It is not true that all the people who are heavier are going to be taller, but their average height is going to be a little bit bigger than the height of the person that you started with.